are going to discuss about the title is an efficient deep learning framework for intelligent energy management in IoT networks. Now we are going to see about the overview of our project, that is the abstract. So the main objective of our project is to consume or to forecast the household power consumption by using different deep learning algorithms. Green energy management is an economical solution for better energy usage, but the employed literature lacks focusing on the potentials of edge intelligence in controllable Internet of Things. In our system, we have to predict or analyze the household power consumption. Here, we are used household power consumption data set is taken from dataset repository. Then we have to implement the pre-processing step for avoid wrong prediction. So mainly the system is developed the different deep learning algorithm such as long short term memory and gate recurrent unit for analyzing the household power or energy consumption. Finally, the experimental result shows that some performance metrics such as mean absolute error, mean square error and root mean square error. Then we have to compare the results and we conclude that GRU is efficient. So this is the main objective of our project. Then we are going to see about the flow of our project. First we have to take household power consumption dataset. That dataset was collected from dataset repository like Kaggle, GitHub and UZI. Then we have to select your input data, that is the selected data. So the data is in the format .csv file. The selected input data are carried out to pre-processing step. Here we have to checking missing values. In our data set, we have to check any missing values is present in your data set. If you have any missing values means we have to replace that missing values by zeros or non-values. So after that we have to drop unnecessary columns. If you have any unnecessary columns or if not used in our project means we have to drop that unnecessary columns in priorly. The pre-processed data are carried out to data splitting module. Here we have to split your whole data set into test and train. Test is used for prediction, train is used for evaluation. After that we have to implement normalization module. Here we have to normalize our whole data set by using min-max scalar. Then we have to implement classification module. Here we have to implement different deep learning algorithm like LSTM and GRU. Then we have to estimate some performance metrics like error values. Then we have to compare the results. So this is the flow of our project. Now we are going to see about the demo part, that is the output of our project. So this is the output. So we are run our project in Spider IDE from Anaconda Navigated. Okay, so this is the input data. So we have to select your input data by using pandas packages. So here we are displayed some sample of input data from your data set. Then pre-processing step, this is the result for before checking missing values. These are the count of missing values. So one means these corresponding attributes contained one number of missing values, so we need to replace that missing values by zeros for avoid wrong prediction. So 0 means there is a no missing values in this particular column. After checking missing values, so 0 0, so we have to replace that all missing values by zeros. Then data splitting. So data splitting means it is the total number of data is present in our data set. This is the total number of test data and this is the total number of trains data. Based on ratio we are splitting your whole data set. Then we are implemented two different deep learning algorithms. One is the long short term memory. So the performance analysis for long short term memory, that is the we are estimated some error values because it is a regression type, so we need to estimate some error values. So these are the error values, and error values must be low. So which algorithms contains the low values means it is a better and it is a efficient. Then this is the GRU, gated recurrent unit. So this is the performance analysis for GRU. When compared with the two algorithms, so GRU is efficient. Then the prediction, the power consumption for sample of data we are predicted with the help of algorithm, that is the with the help of GRU algorithm, because GRU is efficient for our project. So that's why with the help of that algorithm we are predicting the power consumptions. So this is the output of our project.